Hello students, in the last class we learned about the composition of compressor rotor blades and the three ways to connect the rotor blades to the impeller drum. Today, we will start to learn about the compressor stator structure. The compressor stator is the non-rotating part of the compressor consisting of a casing and stator blades. The figure shows the compressor stator of the WP6 engine. Next, let these learn about the stator casing. The shape of the stator casing is generally a thin-walled cylinder with a cylindrical or conical shape. It is connected to other casings at the front and back and has various forms of grooves on the inner wall to fix the stator blades. The engine rotor is supported in the casing, and some engine mounting sections and accessories are installed on the outer wall of the casing. As shown in the figure, this is the compressor stator of the turbojet 6 engine. You can see that its bleed valve component is located on the outer wall of the casing. We can think about what is the role of the compressor stator casing. The compressor stator casing has the following three functions. First, it forms an airflow channel to improve the efficiency of the compressor. Second, the stator casing fixes the stator blades and supports the rotor and plays a role in bearing and transmitting loads. Third, the casing is inclusive and can prevent the blades from breaking. The blades flew out, destroying the aerodynamic layout of the aircraft. Next, let these look at the design requirements for the compressor stator casing structure. First, the overall weight must be light and have sufficient strength to withstand various loads. Second, there must be sufficient rigidity to ensure that the radial and lateral deformations of the casing are within the allowable range under various loads. Third, the concentricity between the various sections of the casing and between the casing and the rotor must be guaranteed. Fourth, it must ensure that the casing will not be punctured when the blades break or the disc ruptures, and it must have a certain tolerance. Fifth, it must reduce leakage losses and the radial gap between the rotor and improve compressor efficiency. Sixth, it must be easy to assemble, have good processability, good maintainability, and detectability based on the compressor, rotor, and stator blade scheme, casing material, and manufacturing method, and stator casing design requirements. The compressor stator casing can be divided into the following three categories. The first category is an integral casing, the first type is a half-type receiver, and the third type is a segmented receiver. As shown in the figure, the high-pressure compressor casing of the JT3D to 3B engine adopts an integral casing. The integral casing has the advantages of light weight, less processing, and uniform circumferential rigidity. However, the compressor assembly is relatively complex, the scheme adaptability is poor, and there are few rotor schemes and rectifier schemes that can be adopted. It is generally used for removable rotor solution. As shown in the figure, the half-type casing used by the WP6 engine. Since the compressor rotor of the WP6 engine is a non-detachable drum disc rotor, the stator casing adopts a half-type casing. The half-type casing has strong adaptability, simple assembly, and easy selection of rectifier and rotor structure. However, solve the connection, positioning, and sealing problems of the longitudinal joint surface. As shown in the figure, the segmented casing used by the WP7 engine. Since the second and third stage low-pressure rotors of the turbojet 7 engine compressor are non-detachable rotors, in order to solve the assembly problem, the low-pressure compressor casing is segmented, consisting of the first stage casing and the third stage casing. The segmented casing also has uniform circumferential rigidity. The rotor solution has the advantage of strong adaptability. After learning the basic types of casings, let's take a look at how the stator blades are connected to the casing. The stator blades are installed in the casing and are located between the two-stage rotors. The connection plan for the stator blades should be closely linked to the plans for the rotor and casing. There are three common ways to connect the stator blades to the casing. The first is a T-shaped tenon connection, the second is a threaded shaft diameter and a rectangular plate connection. The third is welding, as shown in the figure. This is the T-shaped tenon connection method. This method has a simple structure, reliable connection, and the blades can be disassembled and assembled, but it requires a thick casing wall and is suitable for cast half casings. In addition, the processing of the tenon groove is not convenient. The T-shaped tenon is used on the compressor straightening blades of the SPA engine. Connect. What we see below is the connection method between the threaded shaft diameter and the rectangular plate. The WP6 engine straightening blades are directly installed in the ring groove of the inner wall of the casing with a threaded shaft, neck, and a rectangular plate, and tightened with a nut. The use of a rectangular plate can reduce the requirements for the thickness of the casing wall and is also easier to process. In order to improve the rigidity of the blade, the inner end of the blade is clamped by a cylindrical pin with a clamp ring, and the inner surface of the clamp ring can be used as a seal for the comb teeth seal. Ring. Finally, we see the welding connection method. As shown in the figure, due to assembly requirements, the WP7 engine ends low pressure compressor second stage rectifier adopts an indirect fixing solution. The outer ring is centered on the cylindrical surface and bolted to the first stage machine by the special mounting edge on the outer ring. The case is connected to the third stage case. Students, in this course, we have learned three types of compressor stator casings and three ways of connecting stator blades to the casing. I hope that students can distinguish what type of rotor scheme is suitable for different types of casings and identify how different compressor stator blades are connected to the casing. You